In this video, I'm going to be explaining arithmetic sequences and how to write and solve them. Okay, arithmetic sequence, a sequence whose consecutive terms actually have a common difference is called an arithmetic sequence. So for example, if we were to look at these different sequences, we go from 11 to 9 to 7 to 5 to 3. Is there a common difference? Yes. Now you might say, well, it subtracts by 2. Yes, it does. You could say either it adds by a -2 or you're subtracting by 2, so the answer in this case would be yes. This is an arithmetic sequence because there is a common difference between every one of these. In between, you are subtracting 2 every time. This next one, from 5 to 8, you're adding 3. Well, 8 to 11, you're still adding 3, you're still adding 3, you're still adding 3. So this would also be a yes. It is an arithmetic sequence. Down here, this is actually not, and the reason is because 1 plus 1 gives you 2, so you're adding 1 each time. But from 2 to 4, you're not adding 1, you're actually adding 2. And from 4 to 8, you're actually adding 4. From 8 to 16, you're adding 8. It's changing, so therefore the answer is no. Again, I mean, there is a pattern, but in this case, since we're discussing arithmetic sequence, they must have a common difference. Not a common multiple, it must be a common difference. So the formula for an arithmetic sequence is this very long formula, but each part does make sense. So A of n is basically representing what is that nth term, meaning if you want to know the 50th term, if you want to know the 100th term, if you want to know the 1000th term, to be able to get to it, what is the formula to get to that nth term that you need? And what you do is, it is your first term, which in this case is 5, that's great, they already told you, plus d. D is the difference between each term. So in this case, d is 3 because the difference from 11 to 14 is 3, from 14 to 17 is 3, from 8 to 11 is 3. And then it's n minus 1. N is going to be the variable because n is wanting to know which term is it you're looking for. If you're looking for the 50th term, you would plug in 50. If you're looking for the 100th term, you would plug in 100 in order to find the 100th term. So in this case, the nth term would be your first term, 5, plus the difference, which is 3, times n minus 1. Or you could simplify it. Go ahead and distribute the 3, and then combine like terms. 5 and -3 is 2. Or you could rewrite it even as 3n plus 2, either one. This is correct, this is correct, this is correct. So if I wanted to know the 100th term of this, I could either keep figuring out what the next term is, or because I have the formula, I can now just plug in 100 into n to find out exactly what the 100th term would be. So in this case, let's find the nth term of this sequence. The first thing you need to do is we need to figure out, is this an arithmetic sequence? Well, the common difference, you're going from -4 to 0, which means you are adding 4. Here, you're adding 4 again. Here, you're adding 4 again. Here, you're adding 4 again. So we know that the common difference is 4. And so the nth term was the first term plus d times n minus 1. We know our first term, it's -4. So -4 plus d, which is 4, times n minus 1 is actually the formula of our nth term. You can either leave it there, or you can go ahead and simplify by distributing the 4. -4 and -4 gives you -8. And so you could also write it like that. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the nth term. Okay, well, here's a problem. We don't know the common difference. We also don't even know our first term. So here's how you actually do a problem in order to be able to have to work backwards to find those terms. We know that the fourth term is 20. We know that the 13th term is 65. We are actually going to do something that's very similar to slope. If we subtract the term, what the terms are equal to, and then on bottom we subtract the actual terms themselves, we will actually find the common difference. So 64 minus 20 is 44. 13 minus 4 is 9. And why did I say 64? Let's try that again. The fourth term of an arithmetic sequence is 20, and the 13th term is 65. Write the nth term of the sequence. Well, we have a problem. We do not know the first term. We also don't even know the common difference. So here's how you would actually solve one of these problems. We do know that the fourth term is 20, and we know that the 13th term is 65. So basically, if we know if the fourth term is 20, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th is 65. That's a 5. We got to figure out how to get in between all those numbers to figure out what the common difference is. It's actually going to be very, very similar to slope. If we subtract the value of those terms on top and subtract the terms themselves, like the 13th term minus the fourth term, we actually will get the common difference. So 65 minus 20 is 45. 13 minus 4 is 9. 45 divided by 9 is 5. Therefore, we know that D is 5. Okay, that's great. There's two ways in order to figure out now the first term. So if D is 5, that means you added 5 every time. So if that's 20, that's 25, 30, 35, 40, 45, 50, okay? So if the fourth term is 20, we could work backwards to find the first term. So if the fourth term is 20, then the third term was 15, the second term was 10, which means the first term was 5. However, what if I told you that the 50th term was 20 and the 63rd term or whatever was 65? You do not want to have to work backwards from the 50th term back to the first term to figure out what it is. So here's how you do it algebraically. Okay, we know A of n equals the first term plus D, which we now know, times n minus 1. So we're actually going to use one of these in order to actually plug it in. I know that the fourth term, meaning if I plug in 4, I know that the fourth term will get me the value of 20. So if I plug 4 into n, remember, this little 4, if I plug it into this little n, okay, n, the whole value of that should equal 20. So therefore, 20 should be equal to the first term, which is what we're trying to find, times plus 5 times 4 minus 1. Because remember, again, we're plugging in the fourth term. We're plugging 4 into n because that's the number of terms we're wanting. So 4 minus 1 is 3. 5 times 3 is 15. In order to solve for the first term, we subtract 15 and we get 5. We have now found our first term. We have D. We can now write the nth term. So the nth term is the first term plus D times n minus 1. And again, you can either leave it like that, or you can simplify it, which I believe will be 5n, just 5n. And there's your answer.